not recording, sorry, I forgot. Okay, if I try to simplify this by finding the equivalent resistance of R3, R4, and R5, will it change my V naught of T or not?
I do not believe so.
Okay. Anybody else? Why? If it will not change, why it will not change? That's what my question is.
Isn't the voltage dispersed the same throughout all the resistors? So if you make an equivalent, it'll still be the same?
Yes, exactly. Yes, because you do not have any component between these 2 points or nodes. These 2 points or nodes. That's why, or these 3. So they have all same voltage. So they have all V naught of T, right? So that's why you will not, what you should say, you will not change V naught of T if you simplify this, okay? So that's why we will just try to simplify the scenario by finding the parallel resistance. Another important thing is that if you have 2 resistors in parallel, you can write this thing, what you try to find. So if this R4 is parallel to R5, you can just write this. But if this is happening, I actually mentioned that before, this will not be equal to R3, R4, R5 divided by sum. Okay, so we should be very careful about that. So when we write parallel, we want to find a parallel resistance of more than 2 resistors, we will use its basic formula. Okay. So which is 1 over RL is equal to 1 over R3 plus 1 over R4 plus 1 over R5. Okay. So we are assuming that we will know the equivalent resistance, okay? So that is RL, okay. So step number 2 will be, okay, first I need to simplify the circuit. So I will do it. Okay. So now my circuit is simplified and I will try to write the equation. Okay. So I will write equation in, okay, sorry. I need to mention that they both are ground. Okay. So I will try to simplify this using, okay. So if I want to attack the problem, so what should I do? If now I want to write the equation for input stage, what I should do? What you should say? What rule should I apply? What do you think? That can help me for the input stage.
Voltage law?
Yes, because you can see in the input stage that we have the series loop, right? That is one loop. So we will write the voltage, Kirchhoff voltage law, KVL. So apply KVL at input stage, and that will be right. Okay, that will give me VI of t is equal to I1 of t R1 plus R2, right? And one more thing I know from this, and which I should define, okay, which is VG of t. What is VG of t, okay? So I need to write that as well. Okay. So if I want to replace I1 of t in this equation, what should I do? Or do you think that writing, replacing I1 of t may help? Because you should keep the target in your mind that we want to have output over input, right? We will see how we will get that, but we need to get rid of unknowns as much as possible, right? You can see that, say that they are unknowns, but you should say that if you see that in an equation, there are three different variables, we want to get rid of them, right? So I1 of t can be written as right? So Vg of t will be equal to or you can just simply apply the voltage divider rule as well, okay? Okay, so now step number 4 is we need to look at the output stage. So output stage is very simple. We just need to solve for V naught of t, but we don't know Vg of t because it is dependent on the input stage. But now we have figured out what it could be. So we just write the formula. So what do you think V naught of t is? Looking at this, what should I write? I can apply Ohm's law, right? Because there is only one source and one resistance. But what but my question is, what will be the equation? Any idea? I mean, rough guess. Yes, go ahead.
The current source, GM VG of t times RL.
Yes, that's true. But what should be the sign?
Currents. Would it be negative? The current's like going towards the negative
Yes,
side of
it
zero.
should be negative. Yes, you're right. Why? Because when we take the loops, right, it's they are like that, right? And as I mentioned, the direction of I1 of t, I suppose the direction of the current in this output stage is the same, right? But it's as the current direction is opposite, so I will use the negative sign. Okay, is it clear?
Yeah.
Anybody else has this, like any question? Is it clear?
I think I'm missing something in like the input and output stages. How do they like relate to each other? Like, is there like a relation in current that they share between each other, or is it?
Okay, yeah, that's a good question. So in amplifiers, you can see that they are at the common ground, right? But as we mentioned that the dependent voltage or dependent voltage source and dependent current sources are dependent on some other things, right? So this is just a model, like the equivalent circuit, but in real, this voltage source actually, it is dependent on Vg of t, right? This is dependent on Vg of t. So what dependent means? Dependent means that it cannot generate its own electricity or, you know, current. It's like a satellite. You can also say that, or it's like a moon, right? Which takes the energy from the source and supplies somewhere else, but it cannot generate by its own. Okay, but it should have the relationship. Dependent source should have the relationship with the source. Okay, so this relationship tells us that how it is related to input stage. In real world, that's what you are asking, I think, that how it applies in the real scenario, like how dependent voltage is implemented in circuits, right? But for now, for the less complexity, we just assume that this is dependent voltage, but in real, it's actually taking its power from somewhere else, okay?
Okay, thank you.
Mm-hmm. Okay, any other question? Okay, so we are good about it. So, so now to make the relationship between V naught and Vi so that we can find out the transfer function as well, we will replace Vg of t in this equation of V naught, okay? Okay, so the transfer function or gain equation will be where Gm is actually the, what you should say, the gain factor or the constant scenario that is given in the case of amplifier. So this is your output over input equation of the equivalent circuit of amplifier. So it is dependent on not only load resistance, but it is also dependent on your resistances of input stage. So these amplifiers are actually very important problem in microwave circuits, or in what you should say, any complex circuit, because we need to amplify the signals many times when they are traveling through the air or through the atmosphere. So that's very important, I think, to know. Okay. So now I am starting third chapter. Okay. But you can always ask question about, you know, second chapter, because the second chapter is very important, and you need to do the practice of the problems. And so if you have any question in the problem, or you need to ask any question, you are always welcome to ask. Okay. So chapter number 3. Chapter number 3 is about nodal and loop analysis technique. So the first thing that comes in the mind, that we already know KCL and KVL. What is the purpose of, you know, doing it again? So we will see what is the difference between simple KCL and KVL and the nodal and the loop analysis, or we call it also as it mesh analysis. So okay, so what is nodal analysis? So are you familiar with matrices, or how you solve matrices or something like that?
Yeah.
Yeah.
You are studying it, or you have studied it in the previous semester?
Currently studying it.
Okay. Okay. So because we will use this maybe here, not too much in detail, but little bit of that information. So that's why. So what is nodal analysis? Nodal analysis actually based on using KCL. As its name suggests that it's related to nodes, that's why, based on using KCL to analyze nodes systematically. So we already have techniques in the back, right? But as the circuit is getting complicated, we want to make them easier and easier for them to be solved. So that's why we are introducing these systematic techniques. So it actually built a system of linear equations. Okay. And it's what you should say, solver techniques are substitution or matrices. Okay. Okay, so I just will go through a little, quick review of matrices. So whatever we are using here, that's it. So I'll not go in too much detail, but I think we need to touch it. So what is matrix? If it is a 2 by 2 matrix, I can write it as A, B, C, D, right? This is a 2 by 2 matrix. 2 by 2 means that it has 2 rows and 2 columns, right? And if I want to multiply this matrix, so with this kind of matrix, so this is a square matrix, and this is a rectangular matrix because it doesn't have the same number of rows and columns. So it is actually, I can write it as E and F. So the order of this matrix will be 2 across 1. So which means it has 2 rows and one column, right? So have you learned about matrix multiplication?
Yeah.
Yeah.
So am I going fine?
Yeah.
Okay, so I want to multiply these two, okay? And when I will multiply them, I need to know what will be their order, like the resultant matrix order, which is dependent on this thing. So the resultant order will be 2 cross 1. But for the matrices to be able to multiply it, we need to check that these two should be similar. Okay, so if they will be matching, only then we can multiply the matrix. Okay, and the other thing we know is that we multiply row by column, right? So it will be AE plus BF CE plus DF, right? So what I did is this multiplied by this in the first row, and in the second, this multiplied by this. Right? So this will give me the resultant multiplication. Okay? So this thing is the matrix multiplication. Okay. So another important thing in the matrices is the what you should say, inverse. I'm not sure whether you reached to inverse or not. Have you learned about that yet?
We have.
Okay. So matrix inverse is, and have you tried to solve the linear system of equation with the matrices?
Yeah.
Okay. So what is matrix inverse? So if I have this equation, where as if it is a, Ohm's law, this should be admittance matrix, because in Ohm's law, you know that V is equals to IR. So I should be 1 over R into V. So it is the admittance matrix, and its order is 2 by 2. Okay. Okay. And if I want to find, if this is known, and this is also known, and this is my unknown. So I want to find V1 and V2. So the way of finding it is, I need to take the inverse of admittance matrix, okay? So which will be written as this thing. So that's will help me to solve that admittance matrix, the inverse and admittance matrix. So there are, I mean, I think you have learned before maybe that there are rules to check whether it can be like inversed or not, or whether I can find its inverse or not, that we will touch upon later. But for now, I think we need to relate matrix to the our scenario. Okay, so that's about the matrices we may learn. So I just want to talk about that. Okay, another thing I want to write. Characteristics of nodal analysis. Okay, so in nodal analysis, there is one very important thing, that is reference node. Normally, reference node is where normally first I need to write this. In nodal analysis, we select a node as reference node. So what is reference node? From its name suggests that all nodes or all things that we talk about are based on that reference. But normally, all branches connect to that reference node. So if I have, this is my source, this is my element, this may be my another source, and these are my nodes. Okay, so what do you think? So if this is my first node, second node, third node, or what do you think my reference node should be?
Maybe 2. I'm not sure.
Okay, no, you're fine. I just forgot one line. Okay, 2. And any other, or have I explained, do you think that I can reduce my number of nodes? Or I just label them unnecessary, like more number of nodes than they actually are?
Yeah, because 4 wouldn't actually be a node, right?
Okay, that's fine. Any other thing that you have observed that should not be a node? So if you closely look, this all is ground, right? So there is no 5, 6, or 7 node. There is only one node here because they are all connected to each other, right? Without any element in between. So this 5th node is ground, right? So all circuit is connected to it. So normally, or I should say this is as 4. And normally we take ground as a reference node because all branches connect or comes to the ground, okay? So that's why am I clear about that?
Yeah.
Okay. So reference node. Okay.
I'm sorry, I got one more question.
Yeah.
Why wouldn't we choose the node that ground is attached to, like on the bottom left of the circuit?
So
Instead of choosing 4, maybe choosing that like number 6.
okay. What I did actually, so this all is the same thing, okay? So it doesn't matter if I draw ground here, if I draw ground here. It's like LT spice,
Oh, okay.
right? Right? So you need to connect only one ground with the whole wire, right? So similarly for your circuit as well, you need to have only one ground. If your wires are connected, so it means that they are grounded. The other thing is why I changed the number, because I wanted to keep them sequential. So even if it is a 7 and I were having only 3 nodes up there, so I will make it 4. That's why. Okay, there's no
Got
special.
you. Thank you.
Okay. So the other thing is there is one reference node. Another thing is we always keep track of number of nodes. And we said that in this circuit, there is it is n node circuit, okay? So there are 4 nodes in it. So in n node circuit, one of the node is reference node, as we write before. Remaining n-1 nodes are non-reference nodes, or you can also say non-zero nodes, because in the reference node, you can say that your voltage is 0, right? So if this is VG, the VG is 0. So that's why I am saying that they are non-zero nodes. Okay, so thing is that as we know already the voltage of the reference node, okay? So that's why we say that the node in nodal analysis, we only lead n minus one linearly independent equations to solve the unknowns, okay? Because our unknowns are n minus one as well. So what I'm trying to say is, equations, okay? So like in this above scenario, there are 3 nodes. So like 3 nodes mean n minus 1 nodes are 3. So we we have to make 3 equations, okay? So that's what we need to know about that as well. So I will solve, a symbolic example so that we know what we really mean, okay? So we are clear about that till here? Okay.
Wait, I have a question. Which node did you pick as the reference node again?
I pick the node, the reference node, which is ground. Or another thing I say is that reference node is the node where maximum number of branches are connected. Someone say that 2 can be the reference node, right? But if you see here, the 2 is already only connected to 2 branches, but 4 is connected to 1, 2, 3, 4, 5 branches, okay? So the node I picked should be connected to maximum number of branches, okay?
Okay, thank you.
So okay. Okay, now I need to figure out the nodes, okay? So what do you think? What should I write? Where are my nodes are? So how many, but you should tell me how many nodes are there? N.
There's 4 nodes.
Yeah.
I would say 3.
3, okay, let's try. Let's see. So this is 1 node. This is 2nd node. This is 3rd node, and this is 4th node, right? Those who are saying 4, they meant by that.
I know the whole bottom is 1 node since that's ground. I thought maybe there's a fourth node where I3 is, but it's probably connected to the ground also, right?
Yeah. So you cannot make these as nodes, right? Because they are also connected to the same volt, like they have the same voltage. So
Yeah.
yeah, okay. So what I'm trying to say is there are 3 nodes and this whole ground is a 1 node, okay? So I will define that this is V1 here in this node, and this is V2 here at that node, okay? So our step number 1 was nodes. So our n is 3, n minus 1 is 2, and because n minus 1 means not 2 non-reference nodes. Okay, so our step number 2 is
So does so it matters how you label the nodes then? Like 1, 2, 3, like
yes. So it matters that your like it's a Norman, symbolic thing that you make your reference node as the last node number, right? But the other nodes should be in sequential form. Like here, what I did is I started from the left-hand side, right? So if you, it's up to you, but normally we start from the left-hand side to keep, to start the number. So they should be in sequential order, and the last number should be of the reference node. Okay? Okay, so define reference node for voltages, which we have already know that number 3 is a reference node, makes V3 is equals to 0 because it's ground, and we need n minus 1 is equals to 2 linearly independent equations to solve 2 unknown voltages. You know that we have how many unknown voltages? 2, which are V1 and V2, right, in our circuit. Is it clear? Or do you think any other voltage that is unknown? I think if I know V2 and V1, I can find rest of the things. Like if you are thinking that this voltage is also unknown, this voltage is equal to V2 minus V1. So I just need to know, or V1 minus V2, it's up to you how you define it, okay? I just need to know what you should say, the voltage V1 and V2 to calculate other unknowns. So there are unknowns that are essential or essential to be calculated, there are unknowns which can be calculated from others, you know, like which are the auxiliary unknowns. So we are talking about the necessary unknowns, okay? So our step number 4 is write KCL for non-reference nodes. Okay, and we normally take current direction as what you should say passive sign convention. So that's what we will follow here too. So our node 1, when we apply KCL, okay, so let's apply KCL there. So in terms of currents, so there is I1, and if I say this is our I2, so my leaving currents are positive and entering current is negative. So I will just write it like this. Can I do that? Right? Am I clear about node 1?
Yeah.
Yes.
Okay, so node 2, apply KCL. What should be the equation? What do you think? What should be the equation here? Seeing the equation of node number 1.
Minus I2 plus I3 plus IB equals 0.
Yes. So minus I2 plus IB plus I3 equals 0. Okay. Okay. So I just need, I think, these two equations to solve my problem, which is finding V1 and V2. Okay. So what I will do, rearrange equation, KCL equations, such that known sources may be at one side. So my equations will be IA is equals to I1 plus I2, and IB is equals to I3 minus I2. Or am I wrong about that? It should be I2 minus I3. Right? So what should I do next? What do you think? Why it's echoing? 1 minute. Okay, can you hear me?
Yeah, we can.
Yeah.
Yeah.
Okay. So what do you think my next step should be? Oh, sorry, 6. What should I do to solve my V1 and V2? How I make V1 and how I will use V1 or V2 here? Because I have all the things in form of current, right? What law or rule should I apply to bring V1 and V2 in the picture?
Voltage law.
Yes, Ohm's law, you mean, right?
Yeah.
Yes, Ohm's law. So let's see how we can apply that. So I1 is equal to V1 over R1, right? So I will just apply that. Plus I2. I2 is, because I2 is also following passive sign convention, plus minus. So I will write it as V1 minus V2 divided by R2. Similarly, IB will be, okay, so IB is equal to, I will define I3 and I2, right? Because it was I2 minus I3. So I3 is V2 over R3, that's simple. But what is I2 here? What should I write I2?
Would it be V1 minus V2 over R2?
Yes, I should keep it same because once I have defined I2, I should not change its sign no matter what or where I am moving for the nodes, okay? I mean, for node 2, I cannot do V2 minus V1 by R2 because it will change I2 sign. So I2 sign is the same, either it's V1 or V2. So that's why I will define it according to its value. So my I2 is this. And my so is it clear?
Mm-hmm.
Okay. So I will simplify the above equations. IA, I can write it as so we already did substitutions before. So we will just talk about matrix in this example. Although we can solve it using substitution as well. So it's not that we cannot solve it using substitution. So I'm trying to make V1 at one place, try to bring V1s at one place, and try to keep V2 at other places, okay? So I am just trying to simplify my equation based on my unknowns, okay? So my V1 here is 1 by R2. So is it clear?
Yeah, I understand that.
Okay, so now you know that there are two equations and two unknowns, right? And we are making, these are the set of linear equations that we have made. So we can put them in the matrix, right? Matrix form. So my matrix form is IA, IB, V1, V2, 1 over R1. I cannot do that. 1 over R1 plus 1 over R2 minus 1 over R2, 1 over R2, 1 over R2 plus 1 over R3. I know it will take a little bit time to understand what I have done, or what you should say, understanding the matrix formation, but it's okay. R2 plus R3 and 1 over R2. Okay, so if you see in this, what you should say, form, that I took IA and IB as it is, then I took two variables that are unknown as V1 and V2. And if you see that, just a minute, let me. Yes, so if you see that I actually took 1 over R1 plus 1 over R2 minus 1 over R2 and 1 over R2 here and 1 over R2 plus 1 over R3. So you need to keep in mind, so it's not difficult to write them in the form of matrix, but you are seeing that this is multiplied by V1, right? Right? 1 over R1 plus 1 over R2 is multiplied by V1. And the second scenario, this is multiplied by V2, which is also happening in the equations as well. Okay, so you can form the matrix like that. And this is our unknown. This is known. And this is known. So we can find the inverse of the matrix to solve it, okay? So do you think that it's hard to make the equation from the, hard to make the matrix from the equation? Or do you have a question about that? I mean, it's okay if we try to learn that. Or did you make that before in your class, in your algebra class, maybe?
We've done similar things with matrices in advanced engineering math. I'm not sure if everyone else has that though.
But so you understand what's going on?
I'll be 100% honest. I've never seen a matrix in my life until now.
Yeah, I'm a little confused as well. If you can
I'm on that level.
Yeah.
Yeah, I haven't really done matrices before either.
Okay, that's fine. So that's for those people I am just asking. So because I want to know the level till where should I explain? So what do you think? What is the difficult part here to understand? Or do you understand this? It's okay. I mean, if you will not ask question, then I may not know, you know?
I think it's just a little weird with having equations in matrices. Like for me personally, I just haven't really done stuff with equations in matrices before, so that's where like my confusion lies. But I get it. It just is different.
Okay. So in the matrices, you just need to think in your head, like we are just putting them in a system so that it will be easy to calculate things, okay? Because sometimes it's easy to substitute for two equations, right? But sometimes they become more complicated so that we cannot just do the substitutions. So we are putting them in a system that can be solved easily, okay? So that's why we are putting our equation in the form of matrices. So if you haven't seen that before, it's fine. We are not doing something extra complicated. We are just trying to put them in a system, in an order or systematic form. So just hang in there, you will get it. Because when we will solve the problems, I think you guys will be doing as much as others, because it's not something that is rocket science. So you just don't have to worry about that. But I will do multiplications again. I will do inverse with you. So just need to focus right now how we converted our equation in the matrix form. So what I did actually, again I will repeat. So I took this this thing and put it as it is here, right, as you have seen. But I took V1 and V2, which are in the horizontal form, in the vertical form, because you can see that in matrices we do rows and columns. So I took unknowns and put it in the column form, and then I actually took these resistors and put them as it is in the matrices form. So making it 2 by 2 matrix with the, so you don't have to worry about like the R1, R2 and this, but you need to keep in mind that this V1 and V2, which are unknown, are in the vertical form, and when they will be multiplied, they will again make sense. So when I will multiply them, I will multiply, it's like I have done in the start, this row will be multiplied with this column. So it will again end up with this type of equation, right? And similarly, this row, if it is multiplied with this column, it will again end up with this type of equation. So it's that we are actually putting them in a scenario that it can be reversible as well. Okay. So I think when we'll do example, we will, learn more about them. Okay. Thank you for today.
Thank you. Have
Thank
a
you.
good day.
Have
Have
a
a
good
good
weekend.
one.
Yeah.
Thank you.
Good one.
Bye.